1, 2, test, 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 test. Hello, testing, 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 testing. Have we got anything? Can you guys hear me yet? I think that might be working now. Cool, okay. Just need to get iPad working. Sorry guys, this is a nightmare. This isn't good. What can I do? Hmm. Um. Okay, got some ideas. Um. Just trying to work out how to fix this mess. What will make this better? Hmm. This is great. Basically, yesterday I decided to upgrade my well, I didn't decide to. Yesterday, my software decided to upgrade on my computer, and it's now I had to reinstall everything last minute this morning, and my iPad is no longer syncing to the system. Let's do the register, and hopefully I will figure out a way to make this work in the meantime. Um, cool. So if you guys could all comment your names, and we'll go through this. Okay, so you got Kezia, we've got Samuel, we've got Carrie, got Frank, Sam, Stevens, um, Dan, we've got Regan, Hannah. That's it for now by the looks of it. Oh, and Zach, yep. So still missing Joseph, Will, Sam, Lottie, Samuel, Casper, and Isaac. Right. Trying to figure out how to make this work. Gonna try a quick fix. If this doesn't work, you guys might have to watch the video from yesterday while I try and get this fixed properly. Which isn't ideal, but better than nothing. Okay, let's see if this does it. Nope, this does not work either. Okay, I'm gonna have to link you to my lecture I did for the rest of this paper on Wednesday, and I will send you guys an email if I can get it all back up and working again. Just let me check where we got to. Damn, sorry about this, guys. This looks like this is just happening every Friday now. So where were we? We were just finishing off that last question on on moments, which I can't seem to find. Okay, maybe it was in the other group. Um, where is the question we need? Okay, so to finish the paper for today then. Yep, that's it. Right, here's the link, guys. Yeah, part C of question 9. That's the link. If you skip to if you skip to 1 hour 4 minutes should do the job. Hey Joseph, I'll take you off now. So if you guys want to watch that just for a minute, just so you've still got lecture happening, while you do that, I'm gonna try and fix what's going on with my connection, and then I'll keep this window open. I won't talk, so listen to the other me in the other video, and if you hear another person, another version of me start talking, um, then that's to say I've fixed it. Cool. Doesn't make sense. Sorry about that, guys. So if you move over onto the other YouTube video, if you keep this stream open in a different tab, um, I will try and sort out whatever problem I'm having. Yeah, right. Cheers, guys. I'm gonna mute my mic now then. So if you guys head over to the other channel, watch those couple questions that we haven't gone through yet, and then hopefully I can sort this out. If you got any questions, comment them in this stream, and I should be able to see them and pick up on them and answer them. All right. Thank. Yeah. Mute mic now. now. Hello, hello, hello. You guys hear me? I think I am back in business. I think we're good. God, how annoying was that? Yeah, cool. So if you guys want to head back to this channel, I'll comment in the other one saying, can I do that? Nope. Oh. Huh. Yeah, Casper. So we had some problems with the with everything. Nothing would connect properly. It was a nightmare, but I think it's all working now. I think I managed to update softwares and drivers and all of that to yeah. So if you guys want to head back, I don't know if you did C&D yet. Sorry, this is a bit chaotic now. You guys comment when you've arrived back in this chat or email as well, actually. Back here, back here, back here. Cool. I'll just send an email as well. So okay, did you guys manage to see part C or part D in those brief 5 minutes that I was fixing things? Or do you want me to go from part C? Partly through C. Yeah, should we just do C? Let's just do C and D. Cool. Oh dear, that's a good start to the day. All right, where's the pen gone? Okie dokie. So we're back. So where we left off from yesterday was we knew the horizontal component of our reaction force, and we needed to find the vertical component of it so that we can then use that to find the angle. So I'm going to be resolving up. So resolve up. Force is up. We're going to get R vertical. So let's just call it R up. Minus, well, there's 4 mg in total, 3 from weight P and 1 from the bar or the plank, whatever they called it. And then we got plus a force on the tension, so we're going to have T sine alpha will equal 0. Right, so we said alpha was, well, sine alpha would be 3/5, so we're going to get R equals 4 mg minus 3/5 of T, and T was 5 mg 3x plus A over 6A. Hoping this will work. This should work, shouldn't it? Well, do we need to resolve up to find it? Because I don't... Yeah, that's not going to work. That was a nice idea of mine, but A isn't going to... We're not going to be able to find A, so we don't want A in our answer. So instead of resolving upwards, I'm going to take moments about B. So if we resolve clockwise about B, we're going to get R up. Still going to get A, aren't we? But it might cancel with my... How did I do this yesterday? Let's just go with it and see what happens. We can always do resolving up as well and solve them simultaneously. So we get r up times 2a minus a time, what's the weight of the beam? Weight of the beam is m, so mg times a minus 3 mg. We worked out x was 2/3 a, so we're going to have 4/3 a. And that should all equal 0. Can't see the 0 there, but it's there. So let's make some more space. So we get 2a r. Yeah, cool. All these terms have a in, so we can cancel out the a's. Minus mga minus 3, and there's a 3 on the bottom, so they're going to cancel. So minus 4 mga equals 0. Cancel all those pesky a's. So we're going to get 2r upwards is 5 mg. So r up is 5 over 2 mg. So we've got 2 mg across, 2.5 mg upwards. So we can do tan of one of those divided by the other to get our answer. So tan beta is 2.5 mg over 2 mg, which is 2.5 over 2, which I think is a fifth. Well, 5/4, yeah. 5 over 4. So your answer for that one should be 5 over 4. Cool. Right, last bit. Rope will break if the tension exceeds 5 mg. How will they explain the positions of P? Well, the positions of P is x. And we're talking about tension, so if we look back at our tension equation, to be honest, I can get rid of it for now. If we look at our tension equation, we know that tension needs to be less than 5 mg. And our tension is 5 mg 3x plus a over 6a. So that needs to be less than 5 mg. And that's going to, whatever value we get here, this inequality is going to tell us where P can be close or furthest from B, from where the rope meets the plank and before it breaks. So divide both sides by 5 and mg, why not? So we get 3x plus a over 6a. Really common mistake, I've just divided by all this stuff. It's not 0, it's going to be less than 1, so be careful with that. Times up by 6a, so 3x plus a less than 6a. Take away a, 3x less than 5a, so x is less than 5 over 3. Is that right? I feel like it should be more than 5 over 3 because we divided by g, and g is negative. Let's just look back at the picture. Got rid of the picture. No, I was right. It should be less than 5 over 3, I think. Tension, rope will break if the tension exceeds. Yeah, I've done this a bit backwards, haven't I? We've got the tension exceeds this is where it starts to break. So that's where it starts to break, that's where it starts to break. So it starts to break when x is greater than 5/3. Cool, that makes more sense. So yeah, when the object is when x, this value here, is more than 5/3, that's when it starts to break, because you got all that mass hanging down on the end. It's going to pull harder on the rope. Yeah, so x is greater than 5/3 is when it will snap. So for it not to snap, x must be less than 5/3. Cool. All right. So the last question, I think. No, it's not. Wait, what? That's there twice. All right. Yeah, this is the last question. Good. So, going to give you guys a couple minutes to do this one. Is that all on the screen? Just about. You can't really see it says U there, but I'll just draw that on. That's a U. Cool. All right. So that is, did I say 15? Yeah, 15 minutes. Can you guys try this one? Starting from. My timer doesn't work either. That's good. Let's do a screen capture and timer reel. Yes. Cool. 15 minutes. Starting from. Oh, wait, what? Yeah, nice. 14, yeah, 14.04 is good for part B. See if you guys can do C and D. I'm gonna give you guys an extra minute, I reckon, because we are. Oh yeah, it's not. Cool. Give you guys an extra minute or two to do part D. Cool. All right. Yeah, let's give it a go. Answers look pretty good from you guys there. So, part A, we are going to be doing. We need to use the fact the height is 3 meters, so we're going to do all vertical stuff. So U, Y. It's going to be U sine alpha. SY is 3. A is minus 9.8. And we're trying to rearrange to get U, and we know final velocity is 0. So v squared is u squared plus 2as. So 0 equals u squared sine squared alpha minus 6 lots of 9.8. Oh wait, let's change that to g because we want g in our answer. Right, u squared sine squared alpha minus 2. Oh wait, sorry, our sy isn't 3, it's going to be 1 because we're only going up by 1. So minus 2g. And if we rearrange that, we get u squared equals 2g over sine squared alpha. So nice and straightforward there. Right, next bit, point T is a horizontal distance of 20. Vertical distance, a height of 0.75. So our vertical displacement to this point is going to be 1.25 minus 1.25. Horizontal displacement is 20. So we want to find angle A. Okay, so we're going to resolve vertically and horizontally and combine them. So resolving horizontally, using for both of these s equals ut plus half at squared. So s is going to be 20 equals u cos alpha t, and that's it. Resolving vertically, minus 1.25 equals u sine alpha t minus half gt squared. Okay, now the problem here is we've got three unknowns. We've got u, we've got alpha, we've got t, but we can we've got another equation here. So we've got three equations for three unknowns. So I'm going to substitute these together to eliminate t, and then I'm going to bring the last one in to eliminate u so that I can find what alpha is. Okay, so if I rearrange the top equation to get t is 20 over u cos alpha, we're going to sub that in there as t and in there as t. And that's going to give us minus 1.25 is u sine alpha times 20 over u cos alpha minus half g of 20 over u cos alpha. Oops, got carried away there. U cos alpha all squared. And that will simplify to give me minus 1.25 is, well, the u's cancel, sine over cos is tan, so we get tan alpha times 20, so 20 tan alpha, minus 20 squared is 400, half that to get 200, so we get 200g over u squared cos squared alpha. Okay, last bit. So we're going to use this to get rid of u in the equations. So this is going to become minus 1.25 equals 20 tan alpha minus 200g over 2g over sine squared alpha times cos squared alpha. So on the bottom there we've got cos over sine, and cos over sine is cot, but that's on the bottom, so we've got 1 over cot, which turns into tan. So minus 1.25 is 20 tan alpha. So yeah, the cos over the sine, 1 over that is going to give us a tan alpha. And then we've got 200g over 2g, which is going to turn into 100. So we get this equation. And if we solve that, we get find tan alpha. I think tan alpha comes out as, I can't remember now. Damn. What's it going to be? So equation solver. And we got, oops, that should be squared there. Minus 120. So yeah, tan alpha is a quarter, which leads us to alpha is 14.04 degrees. Cool. Not too bad. The rest seems pretty easy. State limitation that could affect your answer. Well, the particle isn't a point, so that'd be one. We not included wind. Air resistance, yeah. Yeah, things like that. Alright, next one. Find the time taken to go from A to T. Cool. Right, to go from A to T then. So we can either go. Oh, we might need to do both again. Damn it, I've erased all that already. So if I come up with those equations again, well, let's start by finding u. U squared is going to be 2g over 2. What am I talking about? Over sine squared 14. So u squared u squared is 334.8. So if I square root that, we get u is 18.3. And then we can just look into horizontal or vertical. Let's go horizontal because it should be easier. So 20s equals ut. So that's 18.3 cos 14 times t. So 18.3 times cos of 14. Divide 20 by that. Oh, you guys got a way different answer to me. Because I typed it in wrong. Yeah, 1.126. Yes, 1.13. Nice, good job. Okay then, that is that paper done. Sweet. So we're going to move on and do the paper that we were looking at yesterday. Oh, sorry, let's go back. I skipped that pretty quickly at the end there. So if you guys do need to copy that down, go for it. All right, so we're gonna try a pure paper now. So pure paper. I think this one. This was 2018's real paper. As soon as it load. Right, so if you guys could try this one, I'll start the timer now. I think. Cool. Right, back to this then. Yeah, well done, guys. So yeah, everyone that's commented got it right. So we're using the fact that 1 minus cos turns into 1 minus 4 theta squared over 2, in brackets there, over, we've got 2 theta, and sine 3 theta is going to turn into 3 theta. So we get that. So on the top, we're going to get 1 minus 1 takes away, becomes 0, minus and minus is positive. 4 squared is 16, so we're going to get 8 theta squared on top, divided by 6 theta squared on bottom, which is 4/3. Yeah, there we go. Can't hear me, really? Should be working. Let me know if still can in a second. Yeah, theta squared on the bottom because you got 2 theta times 3 theta. Cool. Right. Next one. So 7 marks. This is a standard kind of differentiation question. See Cool. Yeah, looks good to me so far, guys. Let's go through it then. So we need to rewrite this one as x squared minus 2x minus 24 x to the power of half. Then differentiate that 2x minus 2 minus 12 x to the minus a half. Differentiate that again, 2 plus 6 x to the minus 3 over 2. So that's all the differentiation done. Verify has a stationary point when x is 4, so we're going to put 4 into dy dx. 2 lots of 4, take 2 minus 12 lots, 4 to the minus half. 4 to the minus half is going to be square root of 4, which is 2, to the power minus 1, which is 1 over 2. 1 over 2 times 12 is 6. So we get 8. Take 2, take 6 equals 0. Therefore stationary. Part C, determine the nature of the point. Well, we then need to put 4 into the second one. So we get 2 plus 6 lots of 4 to the minus 3 over 2. And that's going to be 6 over 2 plus 6 over 8, which is greater than 0, therefore min. Nice, nice and easy. Cool, right, we've 15 minutes left. Let's try and get one more question done. Maybe two. This one doesn't look too bad. So 4 minutes for this one. See if you guys can remember the equations and do this one. So starting now. Nope. Starting Cool. Yep. Look good to me. Route 33 seems right. So first one, we know the area is 11. So area is half r squared theta for the area of a sector. So 11 is half r squared theta. Okay, and we're told the perimeter is 4 times the length. So the perimeter is r2r plus r theta because L equals r theta. And that is 4 times, perimeter is 4 times the arc length. 4 times r theta. So if we rearrange this, we can get 3r theta is 2r. Cancel the r's, and we get theta is 2/3. So we can stick 2/3 into there to get 11 is half r squared times 2/3. I get 22 there is 2/3 of r. So 33 is r squared, so r is root 33. Cool. Right, see how we do for time on the next one. Ooh, maybe. Yeah, if you guys give it a go, if we don't manage to get through it, we'll start here on Monday. So 4 minutes starting from now. See how you do. Cool. Right, let's see if we can just get through this one quickly. So, to show that alpha is between 3 and 4, we're basically trying to show this point here is in between 3 and 4. And to do that, we're going to use the whole change of sign thing. But usually the change of sign is when we're talking about roots. So we need to turn this into something that will have a root on the x-axis. So the point of intersect there is when 2 ln 8 take x equals x. Yeah, when the two lines equal each other. If I put that all on one side and get 2 ln 8 minus x, we could call that a separate function. And the root of that function is going to be the same as the intersect of our two functions on the graph here. So we're going to do f of 3 and f of 4. Work out what those two are, so we get 2 ln of 5 minus 5. Is that right? 2 ln 8 minus 3. Oh no, sorry. 2 ln 5 minus 3, which is 0.22. And 2 ln of 4 minus 4, which is minus 1.23. Therefore, change sign, continuous, therefore root. Okay, 5 minutes, yeah, we'll finish this. Okay, so then we're using the iteration formula. And they want us to determine whether the iteration formula can be used to find a root. So basically, this is asking us to do a cobweb diagram. So if we start at 4, go up to the function, across, up to the function, across to the line, back to the function, back to the line, back to the function, back to the line, back to function. And you can see I've drawn it pretty badly there. Can I do that any better? Yeah, maybe. Let's function, line, function, line, function, line, function, line. There you go. So draw a cobweb diagram, and then yeah, it looks like it converges. So say cobweb converges, cobweb converges. Therefore, iteration will work. Done with you said? Must cross since both lines are continuous. You haven't really shown it's between 3 and 4 though, so no. Sorry. Alright, yeah, cool. So we are up to question 5. I'll just put a little marker to say that. Sorry about the chaos at the beginning, guys, but we got it resolved in the end, which is good. Comment above it. All I can see above it is root 33, Dan. So I don't know if your other comment didn't send properly. But yeah, keep doing assignments, guys. Keep revising. Make the most of this time to get your math skills nice and high. And I'll see you next week. We'll finish this paper, and then we're going to do some more kind of topical revision. So I want to do like a lecture on how to model. Yeah, they're not sending. I don't know what's. If you're typing in algebra, maybe that's having a problem. I don't know. Send me a message on Teams if you want, Dan, and we'll go over it there. Yeah, cool. Message if you need any help, guys. But I will see you next week. So yeah, Dan, send me a message on Teams.